So, welcome to this tutorial about point cloud annotation for semantic segmentation task. First of all, let me introduce you to machine learning on point clouds very briefly, and then let's discuss how data needs to be annotated, how training data needs to look like, and then we can go into the annotation process itself. First of all, if you want to use some library, for instance, the Minkowski engine here, that can be used to train a model to perform the semantic segmentation task, where the semantic segmentation means that every point of the point cloud is assigned a certain object class. You need annotated training data. That's what's on this in this picture here, what's demonstrated. Left hand you have the original raw data, on the right hand you have the annotated data. To perform this, there are several data sets out, of course, but to perform this from raw data that, for instance, you have captured yourself, you need first of all, you need a tool to work with the point clouds. Now, what we suggest and what we use is to use CloudCompare, which is an open source software that is frequently updated and maintained. And CloudCompare can handle multiple tasks for point cloud, also to compare point clouds to each other. And it has very useful tools to segment and annotate point clouds as well. Now, if you check out the CloudCompare homepage, you have, of course, the download button, and then here you can get the version for your system that you need. There is also there are also tutorials here. There is a documentation. This is the CloudCompare wiki, and this is a very comprehensive description of all the tools that are in CloudCompare. First of all, let me check tools and algorithms. Now here you see all tools that are available. And also a list of all methods by the menu entry. Now here you have tools and segmentation as well. That's what we are going to use. And for the segmentation tool, you have cross-section, label connected components. So that's where all the tools would be explained. And also you can use Google to access the right page of the wiki itself. Now let's start CloudCompare that I've installed here on my machine. I use the latest stable version, which is the 2.12 Kiev version, but there is a development channel available as well, but this is likely to break, so I would recommend using the latest stable channel. First of all, this is pretty intuitive. We open a point cloud. Now this is a file called raw. This is essentially an example point cloud, but it could be one that you have captured on a site yourself. Then if you open ply files, there's always this dialog that you have to check with apply all. Now this is a very small point cloud example, but I think this will help this tutorial to make this more comprehensive. If you have very large point cloud sets, it might be necessary to split it into multiple scenes and then do the annotation on the scenes themselves. Depending on your memory size, CloudCompare might also break with very large file sizes. So you can estimate that if you have a point cloud, you need 2 to 3 times the memory space available. Then would be the point cloud file size. So if you have a 10 gigabyte point cloud file, for instance, you need at least 30 gigabytes of RAM memory to open and work with it. Otherwise, CloudCompare will break and not work anymore. So this is, and under these circumstances, it might be necessary to actually, just split the point cloud and do it in multiple scenes. Now, this is the very basic navigation in CloudCompare. You have the rotation tool with the left mouse button, and you have the right mouse button for the pan tool. This is basically what it's all about. Now, first of all, the very basic thing in CloudCompare is that you have this database tree or sort of this file explorer. That's why you see all clouds or all entities loaded in CloudCompare. For instance, we have this raw cloud under this file here. And then there is an org tree just behind this file, but this is calculated by CloudCompare, so we have to ignore this. This is used for visualization and other file handling purposes. So if we untick this box, of course, the cloud will become invisible. If we tick it again, it becomes visible again. If you have loaded multiple entities, it's crucial that you select the entity you want to work with, because only in the selected entities, for instance, you can segment points or also work with the point cloud itself. A very basic tool is the point picking. You can use this to investigate points in the point cloud. For instance, if I click this point here, then I get the information about the point, the XYZ coordinates, and also the RGB value. There can be other information attached to the point. These are so-called scalar fields, but in this case we don't have any of these. So this is a useful tool to inspect the point cloud. And if I do this here, you can see that we basically have more or less natural textures here in this point cloud, and we can always see the actual RGB value. Now what we want to achieve is that we have per point the information to what object class this belongs. To do so, we need to segment parts of this point cloud. Now I close this tool. Again, I have to select the point cloud, and then I have two tools. One is the cross-section tool, which works with such a box that you can drag and drop here, or that you can drag to size that you need. To use the panel tool, you can also move it around here, and then you can actually slice a point cloud with these two options. First one is export selection as new entity, which we are going to use now, and export multiple slices. This would be like if you want to split a very large file into 10 sub clouds, then you can use this one and it goes into the specified directory multiple times. But we are going to use this one, export selection as new entity. Now this is, now let me explain how this tool behaves here. First of all, we will uncheck this one, and that's the section that we just did from the original point cloud. The thing is, it doesn't really segment or extract a segment or a part of this point cloud from the original file, because the original file is still, you can see it here, completely as one. And actually this is not the perfect behavior for the purpose of data annotation or point cloud annotation, but in some cases this is a useful tool. Now nevertheless, I will keep this here for now. I will uncheck it. I will use this raw original cloud again now, and we'll use another tool, which is the segmentation tool, segment. Now, for instance, if I want to segment the window here, what I do is that I use the polygonal selection here. Let's activate polyline selection. You could also do the rectangular selection, but in most cases the polygonal selection is the best one to choose. And then you have to use the left mouse button to open this polygon, and then close. You see the polygon is still open. I could add another point. Now to close it, I have to right click, and then I have two options. One is segment inside and one is segment outside. Now what you can see here in parentheses is the shortcuts for this. I highly recommend using these because it makes work much faster. Now as I want to segment the window, I will choose segment inside. Now already many points have disappeared, but I still have like this one here, and I still have some other things around this window that I need to remove from the scene. Now, what is helpful if the cloud is aligned to the coordinate system here, you can use, for instance, these front views. Okay, so this one would work. So this is a side view, but it actually is it's no point about what it's named. And now I can continue the segmentation. It says segmentation paused here, and with the blank space button, I can unpause the segmentation and then again do a polygonal selection of this window here, white window here. And again, I close the polygon and type I to do a segment inside. And then my segmentation is paused again. All right, then from the very top view, now I have to look into it, but yeah. Okay, so from this perspective here, for instance, I can remove these parts from the wall. So I will unpause the segmentation, again do the polygonal selection. Now I'll do it the other way around and tick and type O, which says segment outside, so remove the outside points. And then now I have the window segmented itself, and then I accept the segmentation with this, could also use enter here. And now what I have here are actually two clouds now. So this one is the segmented one, right? So if I uncheck this, these segmented points are removed from the original point cloud. And this is of course very useful to work with this data and like extract all the windows here and take these sort of in that sense, take these out of the point cloud and segment these for the annotation. Now what I now do is I rename this one. I call it window 001, just that I have an overview on what I've segmented already and that I can continue working on this. Now for the next window, I will actually do the same. I can like improve this process a bit if I use these views here. And now I need to be careful because to select the right cloud again, I will uncheck this one. Now I've selected the raw cloud remaining. So now I'm going to use the segment tool again, polygonal selection. Then I will do, of course, the selection again, right click and segment inside. Now I need to check what's left here in this point cloud. I think I will do this from this perspective here. Unpause the segmentation, again do the polygonal selection right here, around here as well. Right click, segment inside. Okay, this is all right. There are a few of these wall colored points left, but that's what we can accept. Then I check this one again with confirm segmentation or enter, and I get the second segmented cloud. Now this one of course is window 002, it's the second window, and I have the remaining cloud again. Now I will again check this box here, then work my way through the windows. Now I need the right view here. This one's not the right one. I guess this one would work, yes. Of course, what you can do, you could also think of some better workflows, for instance, and do multi-element segmentation in one go. For example, I will demonstrate it here. I'll take the outer boundaries of these two windows now. Do a segment inside. Then, of course, I need to remove these parts of the wall. Unpause the segmentation. Do a segment outside. Then I need to remove all these points back there again. Do just like go around here, close it, do a segment inside again, and then yeah, there are a few points left up here that I will remove. Unpause the segmentation, just go around here, up here, and do a segment outside. We want to remove these points. Now this is good. I can accept the segmentation with enter, and of course have these points here left. I will rename them again. It's going to be the window 003. I don't care if these are two windows because we don't have to work on the level of instant segmentation, so I can just accept it like this. And I have to take care of the very last window now. Let me get a proper view for this one. Yeah, there it is. Yeah. And then no software updates today. And then I'm going to use the select the cloud again, use the segment tool, and work my way around the window here. Again, do a segment inside, then do a unpause the segmentation again. Again, do a segmentation inside. Oh, this polygon, like if you are in a situation as I'm now that the polygon does not really fit, then you can just pause the segmentation and unpause it again and start once again with the polygon. Unfortunately, there's no really proper way to re-edit the polygon, so we have to go this way. Segment inside again, then we will remove these remaining points here, unpause the segmentation, like go around here. Now I have to do a segment outside. That's what we can accept. So we hit enter button again and have another window segmented. Window 4. All right. Now let's deal with the next objects. Like the general approach is to work your way through the smaller objects to the larger ones, because this is essentially makes life pretty much as easy as it can get here. So the next thing I will proceed with is going to be the windows, the walls. Now in that case I'm going to use this view here to actually like work my way around the boundaries here. So again, select the right cloud, use the segment tool, work your way through along this outer boundaries, maybe a bit more here, then close the loop. And now we will do a segment outside so that we keep the walls. Now there's a very, very little part of the slab here left. Now this is actually a thing about removing these. Of course we have to be accurate to get good training data, but for instance from this perspective it's rather easy to remove these, for instance until here. Then again do segment outside, then like the same approach we use here. We can follow the line, this edge here, right down there. Again, do a segment outside, and then I can work my way around here to delete all these remaining points. Now, if I'm good with it, I hit confirm segmentation. Now what I have is the wall 001. Of course, it's all walls, so I will just keep it like that. Then I take a view from the side again to take out these columns here. Of course, I have to select the right entity again, otherwise it wouldn't work. Use the segment tool. Now go right here, close, very close to the edge, to the slab. Select these points. Do a segment inside, of course. Then I have all the columns. Again, do hit enter or confirm segmentation. Now this is column 001. And now the remaining cloud here is actually what we assign, or what we call the class floor and ceiling. So we have to like split it in half again in that sense. Now again, use the segment tool here, segment inside. So this one is we will confirm the segmentation. This one is the floor. And now what remains here is the ceiling. I will rename it, and then this is good. And now we have segmented the entire point cloud. Now it might happen that you have some points that you can't really assign to an object class. That's no problem, because we have also a object class which is called invalid. So if there is stuff around that isn't positively assigned to object class, all the rest goes into this invalid class. But here we have a object class for everyone that's here. So we could do fully segment this point cloud. Now I will delete this one. This was this section tool experiment. I will delete this one. Now we have all these entities here. Now what we are going to do is take all these windows and merge these clouds. I have to like select them all, and then there's this button here, merge multiple clouds. Like this one here we want to do no, because we don't care what was the original cloud here. And now these are all merged to Windows 001. Right. Of course, now what we now have achieved is that we have separate clouds of all these objects, which is very good. But what we need to do now is assign object classes. For this purpose, we have set up a repository here that contains some markdown files that include all the objects. Like we have the category building, construction, and interior. Building generally is everything that's part of the structure of the building or not movable objects, so that are firmly fixed and attached to the building. In the construction domain, we have everything related to the construction site, formwork, scaffolding. And in the interior, we have furniture and stuff. So movable objects would go into the interior class. For the building here, if we open this, we can see an overview of the different classes. And if I, for instance, if I go into the wall class, we have an ID that is very crucial. We're going to use this one. There is also, for visualization purposes, there is a color specified here. And the most critical thing that you need to stick to when you annotate point clouds are these definitions here. First of all, we have the IFC entity definition. So that's the definition based on the industry foundation classes Open BIM standard. But this is often very generic. So this is doesn't really give you a hint of how to annotate certain objects. Additionally, we have annotation rules. They describe how you have to work for instance, around the edges, or what's the separation between certain objects and so on. And then we have examples, for instance, one for the image annotation and also one for the point cloud annotation. And here the blue color stuff that you see, that's walls annotated as it should be. For instance, you need to take care that you have really clearly identify the edge between a slab or a floor and a wall, for instance. So this is what you have to take care of. Now, the next step back in CloudCompare is, like, first of all, if you have checked that you have correctly chosen all these objects here, we need to attach the information, what object class this is, to the point cloud. We do this with a so-called scalar field. These can be edited by edit scalar fields, and we want to do a add classification scalar field. Now this classification can be exported in various file formats, for instance in the PCD file, so the point cloud library file format. So this is very useful to actually store this information in and also preserve the original color values that we use in the training and the point coordinates, of course. So for instance, now let's go back. We select the wall cloud. We do edit scalar fields, add classification scalar field. And now the value, for instance, for the wall is 4. So this is the HumanTech ID that you can see here. See, this one was all the examples. This is the HumanTech ID here for wall. Now then I work my way through all the entities. For instance, the floor would be 2, the ceiling would be 3. So I'll take the floor again, edit scalar fields, add classification scalar fields. I'll do the 2 for the floor and just double check, yes, that's correct. And the edit scalar fields, add classification scalar fields, and the 3 for the ceiling. Now you notice that the color changes when you add this scalar field, and that's what you can, like the properties and also the display, you can control it here. If you go back to the RGB colors, that's the natural colors of the point cloud or the points. If you go to scalar field, it goes to the scalar field, and you can also choose the scalar field here. Of course, we only have the classification scalar field, so there's nothing else here. Now we have to do the columns. I think these are not yet in the actual, or we didn't add the classification yet, and also not for the window. So we go to the column, go to the table of contents, column, it's HumanTech ID 14. So we're going to do again edit scalar fields, add classification scalar field, add value 14. And the last one remaining is Windows. In the Windows, again, go back to the table of content, take the window, it's HumanTech ID 11, go back to CloudCompare, edit scalar fields, add classification scalar fields, and it is 11. Okay, right, now we have all the classifications added to these clouds. Now what I'm going to do is 2 things. First of all, I'm going to clone these because I want to merge them later, but still I want to preserve all the separate clouds to be able to work with them or work on them again and like not lose the segmentation, all the segmented clouds. So I will clone the selected entities. Now you can see here these are cloned. Of course, they are absolutely the same as they have been before. Now I will select all these and merge these entities. Again, I don't want to generate a scalar field with original cloud index because that's information that we don't care about. And what I'm now going to do is I'm going to call these labeled. because this is actually the labeled and merged point cloud. That's the result we want to see. Now, saving your work. This is pretty crucial. First of all, you need to select all these entities, and then you have the best option to save your work intermediately is to use a CloudCompare entities.bin file format. First of all, I need to go to the right file path, but that's just for the sake of completeness here. And then I will, for instance, call this raw annotated.bin file, right? I don't need to do the file extension. Windows does it itself, but I'm going to call it raw annotated and save it. And I would suggest that you save your work pretty often during, like in the process of annotating the data, just to be sure that if CloudCompare breaks, you don't lose too much work. Like saving every few minutes is good, so that you don't lose a lot of work. Now we can see here we have this file. Again, this was the raw point cloud. And now we will look at this data here. First of all, what you can see is I can also activate the RGB values, which were the natural colors, and I can activate the scalar field. We have the classification here. And now for visualization purposes, there is a color scale or a color map in here. So the current color scale is blue, green, yellow, red. You can also, for instance, choose grayscale, but generally blue, green, yellow, and red is a very good and color scale with good color differences so that you can see the different values. And in some cases, because there are also IDs, class IDs with 100, you might need the high contrast color scale to get a better difference of these features. But for now, let's work with blue, green, yellow, and red color. Now, what we have achieved is that if I use the point picking tool and, for instance, pick this point here, I do not only have RGB values, but I also have this classification value. So this is the information that we are going to use in the training. And now the final step is to export this information. There are multiple file formats that can handle classification values. There is the LAS file format, but the problem is it can only handle classification values up to 30, I think. So that's not sufficient for our work. That's why we use to export this point cloud and export it for the pre-processing and for the training pipeline. We use the PCD file format. So I pick point cloud library cloud PCD here and give it a file name again. I call it raw annotated, not .bin, but raw annotated, and file type point cloud library cloud. Now hit save, and then we have here this PCD file as well. I will also again save this as a CloudCompare entity, so as a .bin file. Yeah, I want to replace, but I didn't do any changes, I think, so that's no problem. But anyway, now to check the results, if you have saved everything, you can do close all, then you will get a blank window again, and I will open the PCD file just to check what is in it. Now it takes a little while to load it. Now that's what we have here. We have the cloud, as you can see. So it's only, again, as we have merged it, it's only one cloud. So we don't have the multiple cloud entities like wall and window separated again. But we have here what you can see, the scalar field and the RGB values. So this is the data that's going to go into the training pipeline. Now if I close this again, and suppose I would want to edit the annotation, then I would use this file that we have saved, this CloudCompare entity file, because here we have all the different segmented clouds again. And for instance, if I want to work on this one again, change the annotation a bit, then I can use this as a basis and do not have to perform all the steps again. Anyway, the crucial part is, or critical part really is that we need, in this one here, in this file, we need to have the IDs that are compliant with the classification in this GitHub repository. By the way, this GitLab repo is publicly available, and the link is going to be in the video description. That's critical that we have the correct IDs here. For instance, for a window and 11, I can just double check this again. If I use this point, right, this is a point of the window, and it's classification 11. And here we have the actual RGB value as well. So this is critical that this is correct and compliant to the repository and to the explanations, and then this data can be used for further training pipelines. And what's also important is that this annotation is going to comply with annotated images. So we can use multimodal data sets to work in training pipelines and compare results based on image or point cloud segmentation. So thanks for watching. If you are interested in the HumanTech project results, then check our homepage and also the social media channels. We will keep you informed about advances in machine learning and also semantic segmentation of point clouds and of image and RGBD data. Now, thanks for watching. Bye.